Hello, my name is Mrs. Kershaw and welcome to today's lesson about the story of Alexander Fleming and the development of antibiotics. Before we start, for this lesson you will need a pen, some paper or an exercise book, ideally no mobile phone unless you need it to view the video on, so we don't want any distractions. Our challenge today is going to be to describe the importance of antibiotics, and our aspire is to explain why antibiotics cannot be used to treat bacterial infections. But first, a starter. Alexander Fleming was born on the 6th of August 1881. If he was alive today, how old would he be? 30 seconds, off you go. That's right, he'd be 139 years old. Now, in the early 1900s, hospitals were full of people with blood poisoning contracted from a cut or a scratch, and doctors could do little for them but wait and hope, and often they would die. In the 1800s, if you had a sore throat, it could become really serious and get an infection called rheumatic fever. If you developed rheumatic fever, then in all likelihood you would die, as there was no treatment available. That's quite remarkable, isn't it? Because today you wouldn't imagine that anybody would die from a sore throat or a cut to their arm. Today in the UK we're really fortunate because we have access to free healthcare and a wide range of antibiotics for treating all manner of diseases. But the first antibiotic was not discovered until 1928, and as we'll see in a moment, was not used for quite some time after that. So we're now going to watch a video clip, and afterwards I'm going to ask you some questions about Alexander Fleming and his discovery.
This is a story of penicillin, and it all started here at St Mary's Hospital in London. In the early 1900s, a doctor called Alexander Fleming was trying to find new ways of treating bacterial infection. Back then, infection was a major cause of death, even in hospitals. In fact, in World War I, many soldiers died from infection of their wounds rather than the wounds themselves. Alexander Fleming was working in this very room, studying a type of bacterium that lives in septic wounds called Staphylococcus. He made his big discovery on the 3rd of September 1928, right here.
Fleming was cleaning up his lab when he noticed something unusual. By accident, there was a mouldy fungus growing on one of his agar plates, but more importantly, he noticed that there were no bacteria growing around it.
His conclusion was that the fungus must have produced a chemical which killed the bacteria. This was just what he'd been looking for. The name of the fungus was Penicillium notatum, so he called this killer substance penicillin.
Penicillin stops bacteria by breaking down their cell walls. The bacteria get bigger but can't divide. Eventually, they burst and die.
A substance produced by a microbe which kills bacteria is called an antibiotic.
In World War II, the race was on to make enough of this new antibiotic to save thousands of soldiers' lives. Today, penicillin is still an important drug for treating infectious diseases. It's produced on a bigger scale than ever. At this company in Northumberland, they produce over 7 tons of it a day.
But antibiotics aren't the answer to everything. For one thing, some bacteria become resistant, so scientists are always on the lookout for new antibiotics. And remember, not all diseases are caused by bacteria. As yet, we still haven't found a cure for the common cold. Why do you think that is?
Okay then, so what was the major cause of death in the early 1900s? What is the name of the substance that Alexander Fleming discovered? And what do we call all substances that kill bacteria? 3 minutes to answer 3 questions. Off you go. Okay then, so grab a different colour pen, and as we go through the answers, if you need to pause the video to make any corrections or any modifications, then do so. So the major cause of death in the early 1900s was infection. The substance that Alexander Fleming discovered was penicillin, and the substances that kill bacteria are called antibiotics. So again, at this point, if you need to pause the video and correct your answers. Okay, so 1928, and Alexander Fleming discovered his mould juice that was to become penicillin. But that wasn't readily available to make into a drug that could help to treat people's infections. That took the work of Howard Florey and Ernest Chain and their colleagues at Oxford University, and they managed to turn this penicillin that could kill bacteria from the thing that Alexander Fleming found in his laboratory into a life-saving drug. So in 1940, this is 12 years after the discovery of penicillin, Florey carried out some vital experiments showing that penicillin could protect mice against an infection from deadly streptococci. You can see on the left hand side that the mice who were given no treatment all died, but of the mice on the right hand side that were given penicillin, they all survived. This was a huge breakthrough in medicine. So the first penicillin was used on the 12th of February 1941 to treat a policeman. He'd managed to scratch the side of his mouth while pruning his roses and then developed huge abscesses that affected his eyes, face and lungs. The doctors injected him with penicillin and within days he'd made a recovery. This was the beginning of using antibiotics that now we use every day. So how do antibiotics work? We're now going to watch a short video. Afterwards, you'll need to answer some questions, so if you need to make notes whilst the video is on, then please do so.
How do antibiotics work? Pathogenic bacteria in the body cause infections, which can be treated by antibiotics. Antibiotics can be bacteriostatic or bactericidal. Bacteriostatic antibiotics slow the growth of bacteria by interfering with the processes the bacteria need to multiply. These processes include DNA replication, metabolism, e.g. enzyme activity, protein production, bactericidal antibiotics kill the bacteria, for example by preventing the bacteria from making a cell wall. Penicillins are bactericidal. Penicillins include penicillin 5 for sore throats, amoxicillin for chest infections, and fluxloxacillin for skin infections. Antibiotics can be so-called broad spectrum, affecting many different bacteria in your body, including useful bacteria in your gut. Some antibiotics are more narrow spectrum, only affecting 1 or 2 types of bacteria. It is better to use narrow spectrum antibiotics where possible. Most antibiotics have no effect on your immune system. Antibiotics do not work on viruses because viruses have a different structure to bacteria. Viruses incorporate themselves into a host cell in your body in order to multiply. Bacteriostatic antibiotics that affect bacterial DNA, metabolism, or protein production do not attack body cells and therefore do not slow the growth of viruses. Viruses do not have a cell wall, and therefore bactericidal antibiotics that act on cell walls cannot kill viruses.
Right, so now we've seen the video, I'd like you to answer me 3 questions. How do antibiotics destroy bacteria? How does penicillin work? And what do antibiotics not work on? 3 questions, 3 minutes, off you go. So let's look at the answers then. How do antibiotics destroy bacteria? Well, they slow down the processes that bacteria use to multiply. How does specifically penicillin work? Well, it destroys the cell wall. And then finally, what do antibiotics not work on? They don't work on viruses. Going back to coronavirus then, antibiotics cannot be used to treat coronavirus because this is a virus. Viruses exist and replicate inside of cells, and because antibiotics do not destroy cells, they cannot be used to treat viral infections such as coronavirus. That's the end of today's lesson. Please don't forget to complete the Google form and submit it back to your teacher.